Hello and welcome to class number 3. This is dealing with some green screen footage, and more importantly, what I wanted to do is kind of show you folks differences between 35 millimeter stock footage, which we're looking at a playback of right now, and then if we stop this down, some footage from the Red Epic camera. And I know it looks weird, and we'll get to that in a minute. And of course, some footage from the Canon C500. So having said that, let's just kind of get started. The first thing that I wanted to do is just show you a little bit between the differences of the red and the 35 millimeter footage. So if you notice here, we're looking at this, we've sourced this all in just by itself. And I rendered this red footage out myself from the R3D files, and I rendered it out raw so that nothing would be different. So Nuke is actually taking this in and basically looking at it as a Cineon color space and applying its sRGB LUTing to it as it comes in. Now, the issue is when I run the clip tests, as you can see that we've got all kinds of problems. So we're in negative values over here, and some positive values, like the reds are at like 13 and crazy numbers, which is not how the footage is. So there's a couple of ways around it. If we were to take this and just turn it to red log, it does kind of change it out a bit. And now we don't have any of this clipping going on, but it still doesn't, this isn't right. So given the fact that this is how it's coming out, and this is on purpose, by the way, I wanted to show you what we would do if we were to do a raw workflow. So the first step to set this up correctly is to go through and set all our nodes to raw when we bring them in. So when you do that, of course, all your color space interpretation, like if you're After Effects users, how you interpret footage, all of this is going to be grayed out. So just by virtue of doing this, it's basically just the raw data. So let's look at this. Obviously, after checking the raw work checkbox, now it looks very much like a Cineon image does normally, with the exception of one other issue. Up here, we have in the viewer, we have a LUT being applied, which is Nuke's workflow sRGB, which is the default. So if we switch this off, now this is actually more accurate and much more like what you would see if you were to bring in a Cineon plate into Shake After Effects, or in this case, how it looks now in Nuke. Moving along here, let's go ahead and set these up so that they all have the raw checkbox applied. And now that we have our viewing LUT set to none, no LUTing is being applied, and so we are now going to be able to look at all of the footage as it's shot and how the cameras and the chipsets on those cameras actually deliver the picture. The first thing you'll notice with the film footage is that there's grain. So if you step through the red, green, and blue channels, you'll see this grain, which is certainly most prominent in the blue channel, and this is typical of film plates. But if we switch over to the video footage or the digital footage, you'll notice that it's very different. So if we look at the Red Epic camera footage and look at the blue channel, here, let me gamma this up, you'll see that there really isn't grain like you would see in a typical environment. The issue is now it's a digital noise, which in some cases it's actually put in there to some degree to simulate the film grain of a film camera. I've seen that, certainly with the Arri Alexa, but also with some of this other footage, you're just going to have digital noise, especially as the chipsets are being pushed with higher ISOs. So this here, of course, is the Red Epic footage, and then if you look at this, well, we can gamma this down, you'll see that the digital noise in this particular case is very suppressed. So those are some of the big differences right out of the gate with film versus digital. And then the other thing, which I'm sure you probably noticed by now, is the fact that when we look at the three different versions, the color and luma values of all three are strikingly different. So in this particular case, I think it probably makes sense for us to just go ahead and try to balance this stuff out. The first thing that I want to show is how we can basically create a LUT, which will simulate basically a log to lin, and then we can apply that in the viewer through this button right here, which says IP, and that stands for input process. So let me go ahead and demonstrate how that's done. So looking at the red footage here, this is the one that I would like to try to balance out to the 35 millimeter and the Canon C500 footage. This just doesn't feel quite right. So, and we do have this set to raw data, so this is genuinely how it looks. The first thing that I would do is add a log to lin to it. And instead of going from log to lin, we'll switch this to lin to log. And now this actually feels much more in line with the other ones. And so, I mean, obviously we have some major color differences if you look at her jacket and that sort of thing. This looks like this was shot on maybe a daylight film, and that's why it's so yellow. And this, well, now that this is done like this, it looks like the camera was probably white balanced pretty well. These two feel pretty good. Obviously the blacks here feel a little more neutral than in the red Epic case. But let's take this one step further. Now that we've done this, let's go ahead and try to create a LUT. So the way I would do that is let's just work off the film footage. And the way we're going to do this, of course, is just a series of color correct nodes, and then we're going to create a group and name it viewer input, and that will then take over the input process. So to demonstrate, I'm going to take a color lookup here, and let's see, I think I can just do that. And when you do that, we have our master, and we can just take the 2 points and go horizontal. And now, having done that, you can see right away this feels much more like if you were to add a log to lin to film footage. Then the other thing, I think that it's not necessary, but just to make it look a little bit more appealing, we could add a grade node and just kind of white balance this a little bit. So since it's a little too warm, we can just cool this down a bit, and also maybe bring up the values just a hair, because they feel pretty it doesn't get close to white. I mean, I suppose right up in here you might, let's see what the hottest value is. Yeah, okay, well that's pretty close. That's 80% roughly. So I would say that this looks pretty good. Obviously, the other thing that you probably notice with film footage is the fact that you have dust hits from the scans, and this is something that we'll obviously have to clean up. But having said that, let's see how this looks now when we create a viewer input from this. So just hit Command G if you're on a Mac, or Control G if you're on Windows, and then rename it viewer input. And right away it's given us this error, and the only reason why it's giving us that is because we're now trying to view through the input. So if we were to take this off, obviously now it won't give us that error. But if we just move this to the side, and we now look at our film footage and hit input process, why is that not working? Did it not? Viewer input. Well, this should be working. Okay. What's going on? Interesting. Okay. Well, that looks right. It seems that something just went wrong with the actual footage itself. Here, let's try reloading. Well, okay. For some reason, something happened, and just by virtue of reloading the footage, it came through. So now, if I turn the viewer input button on and off, you'll see that we now have a LUT that we can apply to our tree. So this saves a lot of time. If you do have to work in a raw workflow, this way you don't have to add tons of log to lin nodes or anything like that in your tree. You can just look at it exactly consistently throughout. So from your source all the way to your end. And it's essentially the same thing as if we had one of these LUTs in here. So now that we've done that, let's see how we would go about writing this stuff out. Because ultimately, when you are working in a raw workflow, the most important thing is to make sure that you end up rendering exactly what you came in with, so you don't have any color shifts. So the way I would do that, obviously, let's just go ahead and set it up by putting a write node in here. And we'll just go ahead and write one frame, since that's all we need just for demonstration purposes. So to do this, we'll go ahead and create a DPX sequence, because that's how these are coming in. So these are all DPX sequences. So the point is to just go ahead and render out in the same file format that we have here. So I'm going to create a new directory, and we'll just call this test output. And I'll delete this later, but essentially you'll get the idea. And I assume that you all are familiar with the process of rendering out DPX sequences, but if not, this is basically, I'm just going through the directories and just creating a file name, and then the tag 0%04D, which basically means a cell padding of 4 spaces for the numbers, and then the suffix, which DPX. Once you do that, the write node is smart enough to recognize that the file type is a DPX, and by default, it's going to go to a 10-bit. In the case of, this film footage, this is 10-bit log, and so that is absolutely correct. So for the digital footage, we're actually going to do something slightly different, but not too different. Now, the fact that this is coming in at raw means that we also need to set the raw checkbox as well. Now that we've done that, if we want to just render a frame, in this case F7, we can go ahead and we'll render the frame that we're parked on, and there we go. And then I'll just go ahead and copy this, and we'll read this back in. So there it is, DPX. So now we look at this, and this, there shouldn't be a shift, and now there is a shift. Oh, except for that we don't have the raw data checkbox. So now, if you watch these lines right here, these are my viewer lines. It shows which one's active. You can see that there is no change between the raw coming in and the raw going out. So this is a correct workflow process. Now, if we were to, do anything, this would stay in the same color space and bit depth that it was when it was read in, which is exactly what you want. Now for the Red Epic camera, let's see how we would do this. Since we have this color space, this log to lin here, what we can do then is actually we'll copy this and throw this in here and take this back to log to lin. So now technically the before and after is exactly the same. So if we want to just work between these two nodes, now we could do that, and we'll just add another write node, and in this case go back here and test output. What I'll do is just rename this red output, and once again the tag. And now in this case, the difference is with raw data, this is technically 12-bit footage. So if we render this now, this should come back in properly. So we'll read this in. So here's the red, and if we set this to raw, and now we look at this versus this, now you'll see that there is no change in this either. So this is the process for how you deal with both film and digital footage if you are going to work without using the sRGB color workflow. And this is something that is sometimes mandated by facilities. I know also there's a new file format called ACES, and just given the nature of how new it is and some of the anomalies that occur working in the ACES file format, sometimes facilities definitely need to work in a raw workflow there as well. So the next thing that we should do is just take a look at some of this footage. So let's just flip book this. We'll just go ahead and set it to global. And I want to show you something that can happen with Frame Cycler that a lot of people have run into, and that's where when I just flip book this, I ran a flip book and it just gives me one frame, and obviously this is not what you wanted to see because we set it to global, and that's not right. So having said that, let's go ahead and quit this. Let me show you what's going on here. The reason for this is because the frame range is actually this obscure frame range of 91402 to 91451. And even though we have this starting at 1001, Frame Cycler will not make that connection and automatically play it back correctly. So if you have a source plate that you're trying to flip book and it's giving you that because it's an obscure set of frame numbers, then the way around that is to actually plug in what you have in the original range here. So in this particular case, if we just set it to 9140, let me try this again, 91402 to 91451, now we'll have a flip book that looks exactly the way you expect it to look. And so let's go ahead and play this back, and you can see we got lots of flowing hair and quite a bit of stuff going on here for a key. Also, you can see there's a dust hit here, and of course there was one on her cheek. I think it was right around 106. I don't see it now, but I believe it was there. Let's see here. Yeah, there it is. So it's just so fast. So yeah, this is has some crazy technical challenges. Obviously, the biggest issue with this in here, and so we'll see what we can do with this. There are limitations for what you can do, and so in this particular case, we're going to push it, but we're going to do that. The highly technical stuff for the keying for this stuff in the next video. So for now, let's go ahead and step through the various keyers, and I'll talk a little bit about the following, which is going to be the IBK system, which was developed at Digital Domain, Keylight, and then we're going to look at Primat 5, which in Nuke 7, this has a totally different workflow from previous iterations of Primat. So that's going to be the fun and exciting stuff to check out. The first keyer that I would like to look at is the IBK. So let's just go ahead and add an IBK color. So this particular keyer is a little different in that there's two nodes that are associated with it to get an actual key out of it. And the first thing that you do is an IBK color. And essentially, let's go ahead and go to the film plate. Essentially, if we look at this, you see nothing right away because it's defaulting to the screen type, which is blue. So you set that to green since we obviously have a green screen. And then what we're going to do with this IBK color is build what's known as a clean plate. So it's essentially going to look at the value of green, and it's going to make one solid green for which the IBK gizmo, which is the next step, can say, oh, okay, anything that's not this green color is material that we want to save. So let's go ahead and start doing that. The first thing that I always do is we can just tweak this a little bit. So basically we just want to make sure that any part of our mat here, or our clean plate, doesn't have any piece of foreground element in it, and it doesn't feel like it. We want to pull the red up to make sure that we get rid of any red that comes through. And then once you've done that, we can kind of erode that to just kind of really bleed it out. And then the last thing that we typically do is just run the patch black. So basically this is kind of the same process of unpremultiplying and adding a blur and then pre-multiplying back on top, and then it'll create this kind of look. Essentially this now is our clean plate. So putting a dot here so we can add an IBK gizmo. So we're going to branch that off. And then with the IBK gizmo, you'll notice in here we have the background, and then this C here is for the clean plate, or color, if you will. And then the foreground coming from the original plate here. Now that we have the gizmo in the control panels, you can see that it's automatically defaults to the clean plate blue, but in this case it's going to be a clean plate green. Now that we've done this, right out of the gate we should see a matte, which we do. And the nice thing is we've got quite a bit of hair detail. Now you're probably noticing that the level of noise is pretty significant, and one of the things with the IBK gizmo is that it really does create noisy, picks a lot of noise and kind of a sandstorm in its keys unless you denoise the plate. So we can do that too. So let's do that. So there's the denoise, and let's just see what we get out of this. Mind you, let's look at this. We're getting this big, huge anti-sign from the denoise. That's because we need to just adjust the region here. Why it's black, I don't know. It should not, oh, it's because we're viewing through the alpha channel. Somehow I hit the A. So to maximize or to use this effectively, you just drag this beyond 80 pixels, and what I find works really well is just to look for the most flat area where you don't see a ton of tonal changes. So the luma and chroma doesn't change too much. So that what the denoise is looking at then is a consistent amount of grain in a flat 80 by 80 pixel square. And obviously this is much greater than 80 by 80, but 80 by 80 is the minimum. Hopefully that wasn't too confusing. Now that we have this, you can see right away, especially when we go to the blue channel, you can see that it really minimizes the grain. One of the problems though is that we lose a lot of detail. In this case, it doesn't look too bad in the hair, but let's swing over to the other side and see what that looks like. And as I don't know if the microphone is picking it up, but my computer, the fan is going like nobody's business because it's on complete overtime, working very hard to process this. So yes, the denoise is a fairly render intensive or heavy node, but that's okay. If you find that it's too heavy, just render a pre-comp, especially now that you have seen this whole input-output process. That will certainly help you with that. Yeah, this looks a bit heavy-handed on the hair. And also, if just looking at the skin tones, it feels like it almost feels a bit solarized. So there's a couple ways we can tweak this. The first thing that I would do is take the roll off back, maybe to 1, see if that gives us a better result. Not too happy with that. We'll leave that at 2. So I decided to stop it down while the fan was going because it just seemed to be a little bit too much for the purposes of this. So moving along, let's look at this. I just want to quickly talk about the various pop-outs. Whenever I'm using film, obviously film, but even when I use digital footage, I find that a lot of times the film option works better. Then this noise model is basically essentially the degrain or denoise response based on the low luma values. And sometimes you can have slightly better results if you switch this, if it's a little too heavy in the low areas, if we switch this to constant. So I'm just going to do that. You can see right away that it does bring back something, but I don't know that what it's bringing back is necessarily good. It feels more noisy than it does degrained. Well, yeah, it feels a little bit too splotchy, if you will. Then this profile is also, if in cases when the denoise is too much, that if you switch this to automatic, it'll lessen the amount of denoise that it actually applies. And in this case, actually, if we go to 200% and switch that back again, yeah, actually this looks pretty good. Then the last thing I think I'll tweak is we're just going to take this luminance blend down, maybe to about half, and see if that. So it brings back a slight amount of the grain, but not enough to really be as severe as it was. Like if we were to look at the original and this, obviously we're killing quite a bit of the grain. So I think with that, we'll just go ahead and move forward, and let's go ahead and see how the keyer looks with that. Let's see here if I can just, okay. So now let's go to the alpha channel. And so, like I was saying, looks pretty good, except for it is definitely a bit of a sandstorm, which obviously is going to create problems in our composite. So let's just see what happens if we switch this with the, whoa, okay. What this is a result, and the denoise is actually doing some changes to the color as well, which means we need to create another IBK color off of this denoise. And I'm going to set a switch here, and now we can switch between the two this way. So let's look at this. Okay, so let's go ahead and start redoing the IBK color now off the denoise. So just go back here and let's look at the IBK color, the clean plate. And obviously this is eroding quite a bit. This black piece here is obviously going to not work out. So let's just bring this up a little bit. You know what? Actually, I think I'm going to go ahead and start over. So switch this to green, and let's take the green up because it's, there we go, till it just, this area is just filled in with black. And let's see, take the red up slightly. There we go. Now that we have that, let's go ahead and erode just a couple. And let's go back here. And let's maybe start bringing this up. Okay, so yeah, somewhere between 20 and 30. Yeah, something like that. All right, now that we have that, let's see what kind of a difference we have between the two with the IBK. All right, so this is now with the denoise applied, and that's without the denoise. Well, it does take out quite a bit of the noise in the dark areas. And, honestly, this might work, but realistically, I don't know how good this is, because if we gamma this down, you can see that this mat is pretty transparent. So one of the things we could do is to take up our red-green weight to kind of bolster the density of the mat a little bit. And maybe take this down slightly. Obviously that helps a little bit, but we still got major holes in the jacket and that sort of thing. But let's go ahead and move on to Keylight, since we want to get to PriMatte as well, and that's actually kind of the more exciting one since there's so many new changes with it. So yeah, moving on. Let's go ahead and just branch off. Actually, you know what? We're not going to branch off of here. We will branch off of the denoise. So here we have a Keylight, and let's just go ahead and look at the main plate. So for Keylight, the approach that we use for this is that you can take the eyedropper and put it on the color swatch, and then to actually sample the backing color, hold Shift and your Control to sample, and then Option to freeze the buffers, so this way it won't constantly update. So when you do this and you click in this area, it gives us this result. And you can see right away that we are now sampling the backing color. And then if you literally hold your Option and Control or Option and Command and kind of swim around in the green screen area, you can kind of see what's going to give you the best quality result immediately. And just looking at this, it's pretty clear that the denoise is giving us a fairly muddy result. So perhaps in this case, why don't we just see what we get when we sample it before the denoise. So obviously when we do this, we get a lot more detail in here. So yeah, let's just see if we get something around here. Another thing you can do is hold your Shift, Option, and Command down to, marquee a larger swatch. And that gives you kind of a better average of the backing color. So with that being said, I think I'm going to go ahead and move forward with this. And obviously this is not perfect, and it's not meant to be, but just to give you a sense of how this keyer works. And once I turn this over to you folks, I think the idea is for you guys to just experiment with the keyers and see what kind of results you get on your own. And then obviously next week what we'll do is we'll start building an actual key the way I would do it, and try to make it as good as possible from there. So having sampled this, let's go ahead and turn this off so that it's not going to continue to update any further. And I'll just get rid of the sample area there. And now that we have this, just real quickly, what we can do, if you want to change the screen gain, this basically just kind of hardens the matte or softens the matte. So if we were to just up it by 10%, you'll notice right away that the the density of the matte or the backing color more of it'll clear out. But one of the things about Keylight that I like is that it's really good for soft edges. And so typically I leave this by itself. If anything, sometimes I'll even bring it down a little bit to give a softer key, but I can see right away in our case with this particular piece of footage, it's best just left at 1. So we'll do that. Moving on to down the line here, what we want to do from this point is kind of tweak this key. So we could go into things like the screen matte, where if you clip your black, if we raise this, it's going to be similar to the screen gain in that it would basically start cutting raising the black value of the matte. And the same is the converse with the clip white. But where I think I'd like to go instead for this is just to move into the tuning section. So here, this allows us to kind of dial in how we want to treat that matte a little bit more intensely. By default, it starts the midtones at 0.5, and that's supposed to be the gray value. And from that, it calculates the shadow, midtones, and highlight gains. But in Nuke's case, gray is actually 0.18. So if you were to look at a constant and you wanted a gray, you would actually set that at 0.18. So what we'll do is do that here. So now our gray value is set to 0.18. And then from here, we can start to try to bolster this matte in the midtones and lows by adjusting these sliders here. So one of the things that's going to be helpful is to actually look at the values in here. If we look at the original footage here, we can see very quickly that we have high luma values, certainly in the skin tone. This is where we're going to have higher luma values. And then in here, it's a little bit, this is more on the lower side of things. So knowing that, ultimately, none of this is really too dark. It's pretty well lit, throughout. So I don't think that we're going to actually adjust any of the shadow gain at all. But having looked at that, let's go back here and see what we can do to improve this. So the first thing that I would do is take the mid-tone values down so it'll actually beef up this matte right in here. So if we do this, yeah, you can see that we're getting a little bit more in the core area, but it's also bringing in some of this green screen. So let's see what happens if we bring up the highlight gain. And now we're starting to get a slightly better result. And let's just see what happens if we take our lows down. And not much, right? Just as I suspected, it's not changing anything. So we'll just leave that at 1. Okay, so now that we have done this, let's see if we can bring in maybe a little bit more. So it's just a little bit of fine tuning. The idea really is to look at the edges, not be too concerned about this core area. Same applies with the IBK, because realistically, when I look at IBK and key light, my whole focus is just how we're going to dilate or how we're going to dial in the edges for the material. For the main part of the key, I always, or not always, but most of the time, I use Core Matte from Primat. Let's go ahead and move on, since essentially that's giving us a pretty good look. Oh, actually, one thing, in case you haven't used Keylight in Nuke, maybe I should show you quickly about the in-matte component and the out-matte component. So the in-matte is really going to be for your core matte, which we'll look at when we generate one with Primat. But for the out-matte, you could also do that with creating a hard matte and then dilating that out so that it goes well past the edges. But in this case, let's just do a rotoshape so you can see the functional process, if you will. So the out matte is really just a garbage matte, and the way we can do that is just by creating something like this. So now we're going to get rid of anything outside of here. To do that, you got to go in here and plug in your out matte. And once you do that, it doesn't automatically update because it says it's set to none. So the way you would set this, typically you might think that it's going to be the alpha, but actually in this case, what we want is the inverted alpha. So we want to say that out matte is going to subtract everything. It's basically a subtractive option. So we'll set it to the inverted alpha. When you do that, immediately it knocks out all of this. And that's how you would get that result. So let's move on to Keylight, or excuse me, Primat at this point. And we'll take a look at what is new about Primat and how we can best use it. So the first thing we'll do is create a branch off of here, and we'll call it Primat. Okay. So to start off, the first thing that I want to talk about is one of the major improvements with Primat. And if you have not used Primat before, this might not be as impressive because you wouldn't know that it's such a major improvement, but it's this auto compute. And when I click this, mind you, is, as we've been seeing right now, is definitely a challenging green screen. It's the yellowish nature of it is mixing a lot with this woman's hair and making it very difficult to extract a good matte. Having said that, when I created this when I hit this auto compute button, it immediately found a good matte that, not a good one, but it found a matte that actually looks not too bad, given the fact that there is there wasn't really anything to work with. I mean, just out of the gate, it looks at it and creates this matte just with hitting the auto compute button, which frankly is better than what I would do if I were to have set this to smart select background color and use the color sampler and sampled the backing color from here. And I actually want to demonstrate this. So I pulled up Nuke 6.3, and here's the same piece of footage. So let's just run this real quick. And since we're looking at Primat here, if I do the auto compute and you now look at the alpha channel, this is what you get with Nuke 6.3. So you can see right away that the differences between Primat with Nuke 6.3 and Nuke 7, just out of the gate, way better. So that's the first thing I wanted to demonstrate. Now that we've done that, let's move on to some of the other improvements here. In the past, the way we would use Primat is to sample the backing color and then move down the line with these steps here, which basically they're put into an order for which you should work. And the goal was to start sampling, cleaning the background noise, and then subsequently the foreground noise, and then working your way to refining edges. The problem is that while it was good intentioned and actually very smartly designed, it really didn't produce the quality results that Keylight, for example, would produce. And so now I want to show you some of the differences where we can kind of maximize what its strengths are and actually look at new ways of using it. So let's get started on generating a core matte with the new process that they have here. One of the things that I've noticed is the auto compute, while as great as it is for this core matte example, is actually counterproductive. So I'm going to show you by starting over. We're just going to set all the knobs to default. Whoops, that I actually hit set key on all knobs, so Control Z, and set all knobs to default, and we'll reset this. Now once we do this, this is the Primat as you would get it. The first thing that we'll do is we'll go ahead and select the backing color using the color picker. Whoops. And let's go in here, and I would say right here looks good. Let's see how we're doing here. Okay. Yeah, that looks okay. And then let's just move down to cleaning the background noise. What I want to do is get some of this material out of here and maybe take out some more of this, because one of the things that we definitely want with a core matte is not to have any of the background coming through, because obviously using that as a core matte means it will come through in your final output of the key. So the most important thing is to get rid of every bit of backing color or anything close to it. Now that we have that, maybe we'll just try and clean the foreground noise slightly, something like this. And now that we've done that, let's see how this works. If we hit the hybrid render, this is the new thing, and hit hybrid core, it should, yeah, okay, it's still giving me this bar, but the idea is that it's now pumping out a core matte, and we can adjust the erode and blur without having to add those nodes subsequently after the fact. But I can see right now in my demonstration that this is not working the way I want it to, so I'm actually going to start one more time and just redo this one more time. We'll do a smart select background color. There we go. And let me just see what the hybrid render looks like this time around. Yes, okay, so now I can see right away that it's just getting this face area, and if we set our hybrid core to be something like this, it's not going to give us anything else, which admittedly this is not what we want, but at least now I can see that it's working the way I was expecting it to. So let's turn this off, and we'll actually sample some of this. Whoops, that's a clean background noise. And by the way, if you do make an adjustment and you need to go back this arrow up here is the step backwards in Primat, which you will find that is pretty useful. So let's set this to clean foreground noise, and we know we want that. And actually, let's get rid of some of this other stuff in the background noise, which I seem to be hitting the crop box, which is not really too helpful, but that's okay. Now that we've done that, let's just see what the hybrid render gives us. Okay, it's looking okay. And let's clean up some of this foreground noise like so. Oops. It looks like I need to stop down for a moment. Okay, where were we? I had to clear my disk cache because that was creating some problems. So I believe, let's see, the idea was to get some more of this foreground noise out of here. And now I think like that, let's see how this is looking. Okay, now we're starting to look more like what I was expecting. And let's get in here, get some of this stuff in here, and maybe some of this. Obviously we need to see how this looks. Okay, the only issue being that it's still bringing in some of this material here, but we might be able to just do a rotoshape for that. Given the fact that this backing color is not green, that has a lot to do with why we're getting the problems that we are. So let me just try one more time, cleaning some of this background noise, and let's just see what that gives us. Oh, yeah, it actually made it worse. Okay, let's undo that and undo that. Come back here, clean the foreground noise one more time. Okay, so hopefully this will be what we want. Okay, we'll live without that. And then we obviously have these tracking markers in here, which we need to get rid of, but that leads me to one other new feature in Primat, which they now have a mask input. So if we connect this up to the garbage mat we created earlier, we can set the mask to alpha, and it will knock that off. So lastly, to kind of finish this out, what we do is just, for this example, is just go ahead and take a rotoshape and knock out the rest of this. And let me see if there's a way to reset this crop. And what is it? 2056 by, no wait, no, 2048. 2048 by 1556. Okay. So, and it doesn't seem that there's a way to lock this down, which is too bad. That might be a feature request. Okay, moving on. Let's go ahead and set this to 0, and now we can effectively lock that out. Now we have our core mat, and this is ultimately what I was trying to demonstrate, which it's this is pretty cool. And now that we have this, we can plug this into Keylight, if you will, and this core mat will work also with the next step of Primat, which there's this hybrid edge thing, which we'll take a look at in just a second. But if we were to use this now with Keylight, and not hitting a right node, but hitting the number 2 so we can view through this. If we go into Keylight and now take our InMat component and set that to alpha, you'll see right away we now have a much more solid mat, whereas previously we had tons of holes in it. So if we were looking at this, this obviously fixes this up considerably. So that is one of the new feature sets of Primat 5, and let's move on to the other one, which is the hybrid edge. Okay, so next let's go ahead and create another Primat and branch this off. And now what we're going to do is look at the hybrid edge that this output mode will also give us. So we just saw the hybrid core. Let's see what we can do to make the hybrid edge. So let's just go ahead and select, I think, the backing regions somewhere in here. There we go. That looks good. And we'll move forward and clean some of this background noise. I don't think I'm going to get into this because I don't think that this gray stuff here is actually going to help us for any sort of demonstration. That's going to require its own special type of treatment. So, and then for the hair, obviously we want to kind of firm up most of this. And what do we got here? We have this stuff up in here. Now we're getting what looks like a pretty decent mat with hair detail through here. So let's move forward to the hybrid render. Typically, I would start fine tuning with some of these other options, but given the time that we're up against at this point, I want to just move forward. So we'll set the hybrid render one more time and then go here to hybrid edge. And when you do that, now you'll see that it gives us this really nice edge treatment. So if we wanted to use these two together, our hybrid core and our hybrid edge, we could just simply create an over node. And actually I wouldn't use an over because that's actually the wrong math. What we would do is set it to a max. And then if we look at this, we now have our two mixed together, and this is now a key that Primat would not have been able to do previously. So that's essentially what I wanted to show with the hybrid edge and hybrid core. And now there is one other thing that I wanted to demonstrate, which is the adjust lighting. So let's take a look at that. And let me clear this out of the properties bin and go back here and go to here. Okay. So let's just select the backing color one more time, and let's look at the adjust lighting. So when we do this, obviously you don't see anything until you set your output mode to adjust lighting foreground. And when you do this, now if you look at, this is the original green screen plate, and now with the foreground, what it does is it's actually changing the lighting to be more evenly lit. So from here, you should be able to pull a key that's better. Now, the last thing that I wanted to show is actually that actually gave us a better result. The other adjust lighting option, which is the adjust lighting background. And this generates a clean plate. Now, maybe in this case, that's not the greatest clean plate, so perhaps we could try to refine that. So actually, let's just try and redo this. We'll set this to default and reset one more time. And then let's just grab a background here, and let's go through here and firm this up a bit. So hopefully, I believe that should do it. And actually, let's see if we can clean some of this background noise. I don't know that this is going to help us, but all right, there we go. We might not be able to do anything about that, but that's okay. So now one more time, let's go to the adjust lighting. Let's look at the output of the adjust lighting background. And okay, now here we go. This is a much better looking, what do you call it, clean plate. There's still a little bit of red up here, which quite frankly, I don't think, in fact, I can tell you right now that is not going to look good. So one more time, let's just see if we can maybe minimize some of that by cleaning some of this foreground noise out. And let's see, okay. Now that should give us a better result for sure. Now that we've done that, let's take a look at the output of the adjust lighting background. And yes, okay. I'm still not 100% happy with this, but you get the idea. Basically, the new feature sets, of course, that I was trying to drive at were the adjust lighting and the hybrid render, and then of course coupled with the output modes that you have here. And actually, I almost forgot to mention that we do have the ability to treat this a little bit better. So if we were to take our threshold down, so let's take it down to 4 perhaps. And when you do that, of course, now our clean plate is looking even better. And we could actually take our grid size down a little bit too. Let's see what happens. Take that down to 8. Yeah, 12 is actually Good. Now we have a clean plate. All right. So now we actually have a clean plate. And so far I haven't seen results from the IBK gizmo, but just for the interest, let's just go ahead and connect up our switch node and see if it gets us a better result with this clean plate as opposed to the one generated by the IBK color. And well, I can see right now that the one generated by the IBK color is still better. But having said that, at least now we can see what the differences are. But that, in a nutshell, are the new feature sets in Primat with Nuke 7. And let's kind of wrap this up here. Now that you have a good handle on the IBK, the Keylight, and the Primat, I would say the next step for us to do, or for you guys to do rather, is look at the various pieces of footage. I'll include the script, and actually what I'll also do is bring in a background, and I'll leave you with that, which is this here. Let's actually view it through the proper RGB channels. Oh, and also I'm going to set the raw data here, so at least then now it's all within our raw workflow. And I would say go ahead and experiment with the different keyers with these pieces of footage and see how it differs against the, like for example, the Red Epic footage. This, you're going to get a very different result because you don't have grain, and you're going to have maybe some slightly different issues on how the keyers handle the edges as well. So check that out. Also see it with the Canon C500 footage. And yeah, basically have a good time just playing with the 3 different keyers that I showed. And then next week what we'll do is we'll actually put together a proper key and composite it with, for example, this background imagery. And I might also look for some imagery that's fairly dark by nature, so we can do something that would not work together well. And we'll see how ways to make that sing. So that being said, thank you for your time. I know this has definitely been a long lecture this time, and we'll see you next week. All right, thank you.